Hello, you are here for lesson 8.4, which talks about finding the area of a triangle. Area of a triangle is what you're here for. So the basic area formula of a triangle has been for a very long time that you've used is half times base times height. This can only be applied when we know the height and the base of the triangle. For example, if we have a right triangle here, let's say the base is 3 centimeters, and let's say this side is 4 centimeters. Now what happens is, because this is a right triangle, this is the base of the triangle, and this is automatically the height of the triangle, which is the straight up and down. So we can simply use half times base times height to find the area of the triangle, which will be 6, and this is centimeters, so centimeters squared. But when the straight up and down height, if the height is not known, then we are not able to use this formula, and for that we have two situations. If we have an SAS triangle versus if we have an SSS triangle. SAS triangle is when we know two sides and the included angle, and SSS is when we know all three sides of the triangle, but we do not know any angles of the triangle. Given the first situation, if we are in a situation where the triangle is an SAS triangle, which means two sides and the included angle are given, when that's the case, which means you'll be given these two sides and also this included angle, this angle will automatically be C. Why? Because if this is side A, then this one will automatically be angle A. And if this is side B, then this one will automatically be angle B. So triangle ABC, and you can see we have sides ABC. But again, the white ones, the solid white ones are the ones that are known. In that situation, the area could simply be given by half times, very similar to this, one, except the h is going to be replaced using a trig equivalent. Half times a times b times sine of the included angle, which is sine c. And that's the formula we're going to use. However, if instead of side A or B, we are actually given sides B and C instead, so let's say side B and C are known, then we will do half times B times side C times sine of angle A, because when B and C are known, which are these two, the included angle automatically is angle A, hence we will use the second one. However, if we are given side A and side C, then we are going to use half times A times C times sine of the included angle, which will automatically be angle B. So we would use one of these formulas in case of SAS triangle. Instead, if we are given SSS triangle, which means in any given triangle, all three sides are known. Let's say A, B, and C. If the sides are known and none of the angles are known, then we are going to use a formula called Heron's formula. And Heron, who is also referred to as the hero of Alexandria back in Roman Egypt, he developed this formula about 2,000 years ago. His formula says that you can find the area of a triangle by square root of s times s minus a times s minus b times s minus c, where a, b, c are obviously the sides of the triangle, and as we said, all these three sides will be hopefully known to us. And then we will find the product of s times the difference of these two times the difference of these two times the difference of these two. So now what's S then? Well, S is something that can be calculated beforehand, and S will be half of the perimeter of the triangle. Now, perimeter of a triangle is basically the sum of all three sides. So this is the perimeter of the triangle, but if you half it, that gives us the value of S. So depending on these two situations, and we'll talk about a few examples, depending on these two situations, we will use the specific formula. Again, keep in mind, this is also a very valid formula, but it's got its restrictions. I have to know the base, or I have to know the height, or I have to know some means to be able to find that height. And these three formulas here in blue are basically interpretation of this original formula using trigonometry. Well, let's look at an example. Here's an example. Find the area of this triangle round to 3 decimals. Now, again, we have three choices. Do I use the first formula, half base times height, or do I use one of the three trig formulas, or do I use Heron's formula? We have three choices. Now, when I look at this triangle, clearly we do not know the height of the triangle. This is actually an SAS type of triangle. How do I know that? One side is given, which is side A. Side B is given, so I know A. We know side B. And if this is side C, then this has to be angle C. We also know angle C to be 70 degrees. And hence, this is two sides and the included angle type. All right, since I know A, B, and angle C, we are going to use the formula, which is half times the product of the two given sides times sine of the included angle, which will be C. We'll start substituting. This is 30, half is 15, times sine of 70 degrees. And please feel free to plug this into the calculator. When you do that, we will get about 14.095. Make sure your calculator is in radians, and that turns out to be the area of this. No units are given, so units squared. And that's the area of this triangle. All right, let's see. Here's another word problem. Let's see what type it is and what are they asking me. Matthew is planning to fertilize his grass. Each bag of fertilizer claims to cover 500 square feet of grass. So given one bag of fertilizer, it can take care of 500 square feet of grass. His property of land is approximately in the shape of a triangle. He measures two sides of his yard to be 75 and 100. So approximately it is a triangle. Measures one side to be 75, the other side to be 100. And the angle between them is 72 degrees. And not just any angle. If this is his triangular property, then the angle between these two sides is 72. Not this angle and not this angle. How many bags of fertilizer must he buy? So if I look at this question, for him to decide how many bags to buy, I have to first find the area of his triangular land. Now, this is a triangle. How do I find the area? We have three options here. If I consider 100 to be the base of the triangle, then 75 is not the height of the triangle. Height of the triangle would be straight up and down height, which is not known to me, so I'm not going to use the first one. Then I try to see what type of triangle is this. Side, side, and the inclusive angle. So it's the SAS type, because two sides and the included angle are given to me. And when that happens, you can label it however you want to. Let's call it ABC. Then this is side B, this is side A, and angle C is given. So we can use one of the area formulas. Not Heron's formula because this is not SSS type. Half times A times B times sine of included angle. Sine of 72 degrees. And you can simply pick up calculator from here. Once you plug all that in, let's see if I have it here. Yep, it'll turn out to be 3566.46. 3566.46 feet squared area. So we did find the area of the property, which means this entire zone. We have figured it out. Now keep in mind the question's asking me how many bags, and then I learned, all right, well, they told me that each bag covers 500 square feet. So the number of bags required will be the total square footage, 3566-ish, divided by the amount of square footage that each bag will cover. And when you divide these two numbers, it'll turn out to be 7.13. And we need a little over 7 bags, so I can't round it down. I can't say that 7 bags will be enough because we need a little more than 7. So we will have to buy 8 bags because obviously no store is going to give me 0.13 of a bag. So he's going to need 8 bags. I hope that was helpful. Let's see what else do we have. Now I did explain Heron's formula one more time. Heron's formula is utilized in SSS type of triangle, and it comes in very handy to find the area without knowing any of the angles. By the way, here is Mr. Heron, Mr. Hero of Alexandria. He existed from 10 AD to 70 AD, so about 2,000 years ago. He's also known for what we now call vending machines. When a coin was introduced via a slot on top of the machine, a set amount of holy water was dispensed. He's also known for vending machine, Heron's formula that we're using right now, Heron's fountain, and Ailey pile, which I think when I read it was something similar to a steam engine. So pretty cool. We're using his formula 2,000 years from when he discovered it. Here's an example. A garden has a triangular flower bed. A triangular flower bed with sides measuring 2 yards, 6 yards, and 7 yards. What is the area of the flower bed? Now, keep in mind, this is not asking me to solve the triangle. It's not asking me to find the 3 unknown angles. It's only and only asking me to find the area. So you just have to figure out like which formula to use. And in that situation, it's just best to first see the triangle and identify the triangle. Since all 3 sides are known, this is the SSS type of triangle. That's the situation when Heron's formula can be used. And his formula says that the first step you want to do is find S, which is half of the perimeter, which should turn out to be 15 divided by 2, which is 7.5. Once we find S, then the second step is to find the area, which is given by this formula. And keep in mind, everything in here is under the square root sign, s minus a, s minus b times s minus c. And all this is multiplication. These are 4 terms, 1, 2, 3, and 4 terms multiplied and then square rooted. 7.5 times 7.5 minus the first side, minus the second side, minus the third side. Don't forget, we have to square root all of that. I'm going to do one more step just so I have the numbers. I have to find square root of all of this. Feel free to pick a calculator, plug that in, and find the square root of that, which will turn out to be 5.6. As you can see on the next slide, I have it worked out. Yards squared. That is the approximate area of his little triangular flower bed. All right, there's 2 steps, and I did identify this is the SSS type. Here's another one. Find the triangular area. So area question. This is not solve the triangle question. Enclosed by 3 pieces of fencing. So it looks like we have fence here. 123, 150, and 155. And you can quickly identify this is the SSS type. Let's use what Mr. Heron gave us. S will equal half times 123 plus 150 plus 155. And we will divide that 123, 150, 155, 8, 12, and 428, and half of that will be 214. Once I have figured out S, then we can substitute it in step number 2 in this Heron's formula. Don't forget, the first number is S, then we have S minus the first side. It doesn't matter which one you consider the first side, the second side, or the third side. Minus 150 times 214 minus 155. And take it and plug it in just the way it is. Let's see, I don't have it solved. But plug it in just the way it is into the calculator. Don't forget to put the square root sign and make sure that the square root sign just doesn't end at 214. What you can do is you can plug this in first, get that answer to avoid any errors, then take that answer and square root that number to save yourself from any errors. That is it from my side. Bottom line again, there are three formulas available to us. Number one, the very old formula we've used for a very long time. This is only possible when the base and the height are both known. So for one more time, like let's say you have this triangle, this is the straight up and down height. And if this is given to you, let's say 5 meters, and let's say the base is 12 meters, then we don't have to get into any of those complicated formulas. Base is 12, height would be 5, so you can simply use this one. When this is not given and we have other combinations given, um, either SAS, that's when we use one of these three, but if it's SSS, then we can use simply Heron's formula. All right, hope that was helpful. That is it from my